Hello, I'm Henning Diedrich, and I would like to talk about Luerl. I'm the founder and CEO of Eonblast, that is a game company, and I'm the maintainer of eMySQL and Erlualib. Those are two drivers for databases for Erlang. And I'm also the contributor of Erlualib and Luerl, contributor to Erlualib and Luerl, and I would like to talk about how to join Lua and Erlang. Why I'm at this is basically because we are on the hunt for the perfect game server. Of course, that doesn't really make any sense, but what we are looking for is flexibility, empowerment for the game designers, and at the same time the possibility to have a game world as huge as possible, all in one world and not in parallel worlds. And this is Robert Virding. Robert is one of the co-inventors of Erlang, and he in the past did stuff like the Lisp-flavored Erlang, and in the moment he's working on bringing Lua to you on top of the Erlang virtual machine. Robert was really interested in seeing how he could implement a script language on top of Erlang. And so after looking around, he felt like Lua was the most decently found, and actually tried and started to join them, and out came Luerl. Lua and Erlang really have some things in common. They are both very practical beasts. They have been made for a concrete need. And they are really improving on previous solutions, like concrete applications that were there in a certain context where you needed a more powerful solution for the same task. They are both highly specialized in their own way, and they get at the stuff with a truly radical approach. Both packages have portability and robustness as a core feature, and they also share a certain similarity in how they came about. They are both very dictatorial in that there is a close-knit community or a company department or a university department, close community of people that decide where the language is going. And at the same time, of course, the syntax in both languages is very stable for quite some time for similar reasons. Both also have the feature that they have no marketing budget behind them, and so they're quite well known by those on the know, but they're not as well known as some other languages or databases or product packages that have a huge commercial marketing department behind them. And there are also differences. Lua is clearly rather imperative, while Erlang is rather declarative as a language. Lua can be really proud about the magic that it incorporates, while Erlang consciously avoids magic very much. Then you have the obvious difference between Lua having mutable variables, as we're pretty much all used to, I guess, and Erlang going with immutable variables. Lua is really made to be minimized and small as possible, while Erlang really has a huge library and ecosystem behind it that is really what people mean when they are talking about Erlang, that is Erlang OTP. And I would almost say that Lua maybe is a little bit more the language when you say Lua, while Erlang, it's probably Erlang OTP, what people mean most of the time when they talk about features of Erlang. So Erlang is described as a soft, real-time, declarative functional language for concurrent distributed systems. And what's interesting in this context, of course, is that it's a concurrent distributed system, what Erlang is about. And Lua, described as embeddable scripting language, well, we have the embeddable there right away, so yes, why not embedding Lua into Erlang? And at the same time, what we're really looking for at this point is that it is a scripting language with all that comes from that. So if we look at Lua and why we chose Lua, that's carrying alts to atoms here, but at the same time, to recap, what we are looking for is to empower game designers and make it as easy as possible to script game logic. What is new is that we now have a third VM arriving, and that is Luerl. And that is what I'm going to talk about a little more. So, on the other hand, why Erlang? Well, Erlang is very productive, reliable, and scalable. And it's really made for multi-core servers, and not only since a couple of years ago, but since 20 years now. Because in the telecom environment where it comes from, multi-core was a reality for much longer than what we have now in our server centers. Erlang was created in 1986 by Joe Armstrong, and then with Robert Virding and Mike Williams. It's, as we will see, a very simple and functional syntax. It's also very stable, as I said before. It's super robust. That's always been a hallmark of Erlang, really. And it's really made for distribution. It's like Lua, 100% dictatorial, but also absolutely open source. Erlang is seeing some success in the moment in game servers, where big names are turning to Erlang to do server work, at least the glue code between components on the game server side. But the absolute poster child in all things Erlang is Klarna, which is a financial services company that does financial services for e-commerce sites. And they are claiming that they had 30 seconds downtime in the last 3 years, thanks to Erlang. And then we have Erlang in the distributed database field, where Membase, Riak, and BigCouch all make heavy use of Erlang, or are programmed entirely in Erlang. The sweet spot of Erlang is certainly stateful server with high throughput. And the statefulness is also why, for example, Wooga, the mobile games company, is boasting that they were able to replace 200 PHP servers with a handful of Erlang servers. Erlang was built for reliability, maintenance, distribution, and productivity. It was actually built at Ericsson to be the successor to the very successful Plex programming language that was reliable, had good maintenance features, and was good at distribution, but it was not good at productivity. So this is why productivity was built into Erlang's DNA. I would like to tease a little bit more about why Erlang might be worth your time, and it might be an interesting thing to look into it, and could possibly hold the solution to problems that you might be facing. Probably on different levels than where you would usually use Lua for. The magic, how they managed to create a language that can do all this nice stuff that Erlang can do, could be maybe summed up with this list. It's microprocessors, pattern matching, and immutable variables. And I'll be looking at the processes most of all a little bit, just to clarify where the nice synergy between Erlang and Lua might lie. The key to thinking Erlang hinges on these individual issues: the actor model, thinking parallel, thinking functional, thinking processes, pattern matching, and the error handling philosophy of let it crash. If you're interested in that, you'll find a more in-depth presentation on SlideShare that is from the GDC Online from this year. I'll just be rushing through a look at what the process model in Erlang does. The actor model is something that is pretty similar to the object-oriented model. It's also around since quite a while. The interesting thing is that each actor is a complete self-contained machine, and it is this most of all because it doesn't only unite data and code, but also every actor has its own individual process and does not share any data with other actors. Communication between actors is by asynchronous messages, so it's not your function call between two individual objects, but really just do a synchronous function call, which is called a method. With actors, it's really an asynchronous process, and for that they have mailboxes built in, and the whole logic of how these messages that they're receiving are taken out of the mailboxes and processed. In Erlang, you have to think processes, and the very first question, of course, is what should be a process? And it's very important to understand that processes don't share state, they communicate asynchronously, and in Erlang they are very cheap to create and keep. And Luerl opens this door for Lua, so that the prospect here is that you could have tens of thousands or even a million Lua processes all running in parallel. And this is why Lua is, as an architecture, so very interesting. If you compare the process of Erlang with objects in, for example, Java, You would have maybe an architecture that looks like this in an object-oriented language. You have threads, and these threads are kind of populated with individual objects. In Erlang, each actor is a process. And of course, each Luerl state machine is its own actor and its own process. In object-oriented languages, you have situations where you have idle threads. And that, of course, leads you to the concept that you would, because creating a thread is expensive, reuse threads and pool threads. Now with this comes a whole host of possible error conditions where objects could either live too long and not be taken off a thread that is supposed to be empty, or objects could be destroyed prematurely and then be found missing by other objects that rely on them. Because objects usually can share state, there's also a high likeliness that they can propagate errors from one problem spot to another. And in Erlang, you simply don't have this kind of source of errors. Every actor is its own process, and if one dies, which is a normal thing in Erlang, then it's simply recreated and restarted, and this is the major error handling feature in Erlang. The way you handle errors in Erlang is under the headline "Let it crash." That is really a whole different approach to how you think about errors and how you create a system that can cope with any kind of errors, really, even those errors that you might not have thought about. It takes some time to get used to. It's certainly a super fascinating feature of Erlang, and it results in much shorter code. Now, how does the syntax of Erlang look like? Let's just take a very short look at it. As I said before, it's very stable. It's also a small set of keywords and constructs. It's heavily inspired by Prolog and ML, and so it looks really different than the algol hairs that we are usually working with. So this is an example, and immediately this makes clear how declarative Erlang is. This really looks a lot like the math description of the Fibonacci formula. This is a hello world. The first two lines are boilerplate. The second line really is the function head, and then the last line is where hello world is printed on the screen. This is a more complete hello world in a way that this is a real hello world, because in Erlang it's not really a program unless you have at least spawned one process. And this is exactly what happens here. In the start function, you can see the spawn function where the loop function that is in the lower part of the screen is made into its own process. And as a last argument why Erlang might be worth your time, there was a study in 2002 to 2006 conducted by Motorola where they showed that for the problems at hand, they were able to have 2 times higher throughput and 3 times better latency with 3 to 7 times shorter code for what they programmed. Those were telephone switches that they programmed once in C++ and then in Erlang to have a direct comparison. If you're interested in learning Erlangs, here are my tips. There is stuff in the internet that you can turn to. There's of course a mailing list, and you might come back to that list on SlideShare. Now let's look at how Erlang and Lua are being joined. So apart from Luerl, which I'm mainly talking about here, we have Erlualib out there, and that is a library to embed Lua directly into Erlang. This creates a Lua state with the original Lua virtual machine. It's very fast, but it's not as secure as it could be because it can crash Erlang, and it can actually crash Erlang pretty easily by stack overflows. So this is something that is really against the grain of Erlang itself. However, it's a perfectly valid way to do it, and this is how a hello world looks in Erlualib. Actually, what you do here, the first line again is the function head, then the next line is creating a Lua state, then you are putting the print function's name on the stack, and in the next line you're executing it. Lua, on the other hand, is a completely different beast. Now let's look at Luerl, which is a completely different beast. Luerl is a virtual machine programmed in Erlang. This, of course, is the perfectly secure way, and it produces precompiled chunks that you can then execute and reuse also. It also gives you state, Lua state, that is reusable. Luerl is work in progress, and it's done by Robert Virding. And this is a hello world in Luerl. Even if you don't know Erlang, you can see that it's perfectly simple. You have a function head here that's hello, and then you're executing Luerl do with a snippet of Lua code. This is another way to print Lua to make Lua print hello world to the screen, provided that in hello Lua you have print hello world. This is another way to use Luerl that's pretty neat, because here you evaluate a Lua term, 1 plus 1, then return it and store the result directly into the variable a, which is a Erlang variable. And this is much less overhead, of course, than what you have to program to do the same in Erlualib, where you have to transport the variables out of Lua back into Erlang. This is an example where you precompile a chunk, that is the third line, and then execute it. And the interesting thing here is that both the state and the chunk are immutable, and that means that they are always reusable. So the special features of Luerl are, for one, the very fast language switch, which in effect is no switch because you never leave Erlang. You're just executing a Lua virtual machine inside Erlang. Then you are transparently using all the goodness that the Erlang virtual machine gives you with multi-cores and the transparent spreading of load that the virtual machine of Erlang provides for you, which of course then also is available for the individual Lua states that you might be using in parallel. So the promise here is that you could run tens of thousands of Lua processes in parallel effortlessly. The use cases we could see, as opposed to using Erlualib, which is faster, is that if you have Lua code that is really only run occasionally, then it might not be worth it to have the extra overhead to use something like Erlualib, and Luerl could be the nicer solution for that. You could also have Lua codes that are really small, and for that small size it might be worth to use Luerl because the switching between languages in Luerl is so fast. You could also have Lua code that mostly calculates and reads, and that's a special thing here because it's a challenge to implement the mutable variables of Lua in a virtual machine that uses immutable variables of Erlang. So if you use code that does make changes to state, you'll be a little bit slower with Luerl, of course, than using something like Erlualib that switches to this C-programmed virtual machine. If you use Lua state that is repeatedly used to fork up, it could also be a very good basis to use Luerl because, as I said in the previous example, you can be sure that both chunk and state are perfectly the same even after executing code in them. And lastly, if you run massively multi-processes in parallel with each using their own Lua state, then this could also be something where Luerl shines. I did some benchmarks comparing Erlualib and Luerl, and what we see here is that for the safety you get and for the other features that we just discussed, Luerl can be quite a bit slower. And if you execute a formula as given at the bottom of the screen, it can also turn out that Luerl is 10 times slower than the compared C implementation embedded into Erlang. Robert Virding is in the moment working on that, and he is implementing the next level, so to say, of the virtual machine of Luerl that is compiling to Erlang core, which is a language layer below the high-level Erlang compiler. And I'm very excited to see what performance we will see once he implemented that. Luerl, as I said, is work in progress. Stuff that's still missing are label and goto, the tail optimization and returns. It only has very limited standard libraries available right now, and there is no proper handling yet of the underscore meta table. What's coming up is compilation to Erlang core, as I just mentioned, and we'll have more benchmarks for you then. If you're interested and want to get started with Erlang maybe, or want to take a good look at Luerl, here are the URLs. Again, this will be shared on SlideShare, and you might simply go there and look up this presentation to have these links available. If you have any questions, please don't hesitate to email me or ask on the Erlang mailing list, or ask on the Lua mailing list even. Robert Virding is present there. If you're interested in to follow the news development, you might follow Robert Virding on Twitter. And if you're interested in Eonblast, there are also links provided here. I say thank you very much for listening, and I hope this was worth your time.